Hello everyone. In this lecture, we will discuss about lecture number 4, homework solution. Class 12th, chapter probability, lecture number 4, homework solution. So here is the very first question of the exercise, and I hope you were able to identify whether the question belongs to Bayes or law of total probability. So let us discuss the question. It says an urn contains 5 red and 5 black balls. So I am making a box here which has 5 red and 5 black balls. Okay, a ball is drawn at random. You are taking out one ball. Okay, now taking out one ball has two possibilities. You may take out the ball as of red color, you may take out the ball as of black color. Any one ball can be picked out. Now what are they saying after it? A ball is drawn at random, its color is noted. You note the color and is written to the urn. Now you note the color, whether the color is red or black, and you have placed that ball in the box again. Now they are saying, moreover, also you're doing what? Two additional balls of the same color drawn are put in the urn. Now suppose you take out one ball and you note the color is red. Okay, you put that back. Also two balls more of the same color, that means red, you are placing it. So if this event is happening, what is the case of the box? That we are adding two more balls of the red color. So we have total 7 and number of black ball remains same. If we draw the first ball as of black color, the case is we put that in the box. Also we add two balls or black color. Okay, now they are saying after this all has happened, a ball is drawn at random. Now out of these two boxes you are drawing a ball, right? These two cases. Now you are drawing one ball and you have to find the probability that it is of red color. Correct? So we will consider event even that first ball that we are drawing out or we are taking out, that means these balls we are talking of. First ball drawn is red in color. Okay. E2 we can consider as first ball drawn is black. So what will be the probability of even? And E2. Probability of even, first ball drawn is red. You see in the box, out of total balls which are 10 in number, the number of red balls is 5, so the probability is 1/2. Similarly for the black balls. Now let us consider what is the common event happening. Whether you draw the first ball as red or black, at last the second ball that you are drawing is of red color. So the common event is second ball is red in color. Okay, so I'm writing A as the event that the second ball is red in color. Now we have to actually find out P of A. As you can see the statement just says what is the probability that the second ball is red. There is no condition to it that the second ball is red when the first ball is red or black. So no conditions. This is a question of total probability. So we're going to apply law of total probability. As we see, there are two cases in it. So the formula will be P of even. Okay, when even has happened, suppose if the first ball is red, okay, when even has happened, what is the probability of happening of A? That means getting the second ball as red. So you see this is the first case. Okay, so out of these, how many red balls are there here in the box? 7. Total number of balls is 12. Similarly, probability of A given E2. When E2 has happened, that means the first ball drawn was black. So this is the case now. Now of the box, you are drawing out a red ball which is 5 out of the total ball which is 12. Correct? The formula for this will be P of even into A given even plus P of E2 into P of A given E2. You know this formula, we have discussed the theorem also. Okay, P of even is 1 by 2 into P of A by even is 7 by 12 plus P of E2 which is 1 by 2 into P of A given E2 which is 5 by 12. So when you solve it, you get 7 by 24 plus 5 by 24, which gives you 12 by 24, and in the simplest form it is 1 by 2. So the answer for this question will be 1 by 2. Every question in the examination you have to write the formula. You get half marks for writing the formula. Also, to identify the question and what they are asking, what they have given, this all is not given. Just a statement is given. P of E1, E2, A given E2, A given E2. We all have to identify. Also, we need to identify whether the question is of base or of law of total probability. So, I hope this is clear. Let us move to the next question. So this is question number 4. Question number 2 I have already discussed when I discussed a theorem. In question number 4, they are saying in answering on a question on multiple choice test, a student either knows the answer or he is guessing the answer. Let us consider two different events which are given, even and E2. Let us consider even that he knows the correct answer. Okay, knows the correct answer. Event E2 we will consider as he is guessing the answers. Guesses the answer. Okay. He is guessing the answer. Now they are saying 3 by 4 with the probability that he knows the answer. So probability of even is given to us that he knows the answer. It is 3 by 4. Now you see probability that he is guessing the answer. 1 by 4 is the probability that he guesses. So 1 by 4. Now, if a student who guesses at the answer, okay, what is the student doing? Student is guessing the answer, okay, and the answer is correct. The probability that he is guessing and then the answer is correct. So, he has guessed it and then the answer is correct. So, let us consider A as the event that the answer is correct. So P of A by E2 is given to us as 1 by 4. As I can read the statement again for you, if a student who is guessing the answer will be correct, he guessed the answers and then on checking it was found correct. That means E2 has already happened. He has guessed the answer and then the checking has been done and the answer is found correct. The probability is 1 by 4. What about P of A by even? A given even means he knows the correct answer and on checking the answer is found correct. Now you see, if you know the correct answer of the question, definitely you will write that only and that is going to be correct itself. So that is a sure event that if I know the answer of something correctly, I know the answer is going to be 1 by 2, I'll just take it 1 by 2. Correct, and it is going to be correct. That's a sure event. The probability of this will be 1. Clear? Now they're asking what is the probability that the student knows the answer given that he answered it correctly. Please pay attention to this. They are saying what is the probability that the student knows the answer given that, you see, there is a condition applied to this statement. In the first question there was no condition. The question was of total probability. In this question they are clearly mentioning the condition. You have to find the probability that he knows the answer. Okay, he knows the answer given that he answered it correctly. So you have to find out probability of what? That he knows the answer. He knows the answer is even given that he answered it correctly, even by A. Okay, so P of even by A As I told you the formula for Bayes theorem, we are going to write the favorable case of it in the answer. P of even into P of A by even, the reverse probability, divided by the total probability, that means both the cases. We can do it using a tree diagram that makes it easy for us to solve. So let us first do it with this, and then we will be finding it out. So when we solve it and place the values in the formula, I think we have all the four values. See, P of even, P of E2, P of A by E2, and P of A by even. All the four values which are required in this formula, we have that. Can place it and get the answer. So I hope this question is clear. I'll explain it with the tree diagram also. So when you solve and place the value, the answer that you get is 12 by 13. Let us just do it once with the tree diagram also, which makes it easy for us to solve. So see what they are saying. There are two things, event even and E2. First one is he knows the answer. The second is he is guessing the answer. Okay. But at the last the answer is coming correct. That means the event A, which is the common event. That means he knows the answer. That means even. Okay. And the answer is correct. Similarly here, he is guessing and then it is correct. So you have to do what? P of E2 into P of A by E2. P of even into P of A by even. This is the total probability. The only favorable case to us is this one. This is the favorable case to us. So this will come in the numerator, and both the cases with a addition sign will come in the denominator. Clear? Let us move to the next question of it. Here is question number 5. In question number 5, they are saying that a laboratory blood test is 99% effective in detecting a certain disease when it is in fact present. That means 99% effective in detecting when the disease is actually present. That means there are 1% of the cases that it detects when the disease is even not present. Right? However, the test also is a false positive result. False positive result for 0.5% of the healthy person tested. When a healthy person is tested, the false result is also giving us 0.5%. That is, if a healthy person is tested, then the probability 0.005, the test will imply he has the disease even if he is healthy. So you think that is this is not a simple statement, this is a conditional statement. He is healthy and still the test is giving a positive result. Two things are there in it. Similarly, they are saying if 0.1% of the population actually has the disease, that means 0.1%, 0.1 upon 100, that is 0.001 is the probability that the population actually has the disease. What is the probability that a person, what they are asking us, what is the probability that a person has the disease? He is actually having the disease and the test is positive. Fine. They're asking the test is positive. So you see there is a condition given here. Condition is what? That the test is positive and the person had a disease. So let us consider the events according to the question. The event even that he actually has the disease. Okay, he has disease. We'll consider event E2. He does not have the disease. That means he is healthy. Doesn't have a disease. Okay. Then what is the common event? If healthy person is there, still the result is positive, and if the person is not healthy, he has the disease, then also we have been given the probability. A is the event that the result is positive. Result is positive. So let us find out. What will be probability of even that the person actually has the disease? It is very clearly mentioned here, 0.1% of the population actually has the disease. So 0.1 upon 100, that gives me 0.001. So this is the number of people who are actually having the disease, probability of people having disease. Probability of E2 not having the disease will be 1 minus 0.001, that is 0.999. Clear? Okay. Now this is clear. Let us go to other things. Now, if a person is healthy, first of all, let us find out what we have to calculate and then we will search the reverse probability. They are saying the test probability that a person has the disease. So we have to find out that he has the disease. Has the disease means even. Even. Given what? That the result is positive. So we have to calculate this. For this we need the reverse probabilities. That means A by even and probability of A given E2. A given even means that the person is having the disease and the test result is positive. That means 99%, right? Having the disease present and the test result is positive. So 99%, that means 99 upon 100, 0.99. Probability of having the disease or the test positive when he doesn't have the disease is 0.5%. 0.5 upon 100, right? So you can write it as 0.005. Now the formula of this, the favorable case is even and probability of A by even divided by the total probability. That means we are going to add both the cases here, plus probability of E2 into probability of A by E2. So just put the values. We all have the values 1, 2, 3 and 4. These are the 4 values required. We can place in the formula, can get the answer of the question. Clear? So now I think these questions are clear, and then we will discuss about the other questions in the next lecture, which is your lecture number 5. Exercise 13.3, some of the questions of homework as well as the other questions. So that's all for today. Thank you. Bye.